Question A asks us to determine the empirical formula of the gas from the data given to us. First, we take the 95% fluorine and assume the compound was 100 grams. So the 95% fluorine turns into 95 grams, and the leftover 5% hydrogen turns into 5 grams. Then we convert the 95 grams of fluorine into moles using its molar mass of 19, which gives us 5 moles of fluorine. We do the same thing for hydrogen. We convert the 5 grams of hydrogen into moles using its molar mass of 1.01 grams, which also gives us 5 moles of hydrogen. Now we divide each of them by the lowest amount of moles, which in this case is 5. We end up with the 1-to-1 ratio of hydrogen and fluorine, giving us the compound HF. But you have to keep in mind that HF is the empirical formula. While it can be the molecular formula, it might not be, because it never gives us a molar mass of the molecular formula in the description of the AP problem. Question B asks us to find what fraction of fluorine of the original compound is in the solid and what fraction is in the gas. Firstly, we take the given amount of 4.267 grams of UO6 and divide it by the molar mass of 352.03 grams. And then we multiply it by 6 moles of fluorine because there are 6 molecules of fluorine in UF6. And we end up with 0.0727 moles of F6. Next, we take the given amount of 0.970 grams of HF and divide it by its molar mass of 20.01. Then we multiply it by 1 mole of F since there's 1 molecule of F in HF. Then to find the fraction, we divide the 0.0485 moles of fluorine by the 0.0727 moles of F6 and then multiply it by 100 to get a percentage. We end up with 66.7%. So in simpler terms, 2/3 of the fluorine goes to the gas, while only 1/3 of the fluorine goes to the solid. Problem C asks us to find the formula of the solid product. First, we take the given 4.267 grams of US6 and divide by its molar mass of 352.03 grams. And we multiply it by 1 mole of uranium because there's only 1 molecule of uranium in the total UF6. And we end up getting 0.01212 moles of uranium. Then we add the given 3.73 grams of the solid by the 0.97 grams of gas, which gives us 4.7 grams. We then subtract the 4.7 grams by the 4.26 grams of US6 to get 0.433 grams of H2O. Then we use the 0.433 grams of H2O and divide it by its molar mass of 18.02. And since there's only 1 molecule of O in H2O, the fraction of moles doesn't change. And it ends up giving us 0.02403 moles of oxygen. Then we take the 0.07272 moles of F6, which we calculate in question B, and subtract it by the 0.0485 moles of S, which we also calculated in question B. And that gets us 0.02422 moles of fluorine in the solid. Then we take the moles of fluorine, uranium, and oxygen, and then we divide them by the smallest value of moles, which is the 0.01212 moles from the uranium value, which gives us the simplified equation of UF2O2. Question D asks us to write the balanced equation for the reaction of UF6 and H2O. The UF6 and the H2O are the reactants, so they go on the left side of the equation. And since the HF and UF2 are the products, they go on the right side of the equation. For an easy way to balance a chemical equation, you can use the ERP method, as I used right now. And because the question states that the empirical formula of the gas is the true formula, we do not need to find the molecular formula. Otherwise, it would have given us the molar mass of the molecular formula in the description of the problem.